Hi everyone, I'm Locke. I'm here with MatSE 112 Team 2, and we're in 312 Hammond, home of the 3D Printing Club, and we're going to be looking at some cool polymer stuff today.
Polymers is expansive and amazing right now. It is everywhere from technology to weaponry to medicine. It's taking over the world. We're going to have a quick insight to show just how important it really is.
Polymers are a long string of molecules made up of monomers. Monomers are any molecule that has the affinity to stick together to form a polymer. Polymers are also known as macromolecules because of how many smaller molecules make up the polymers. There are basically two types of polymers, linear and branched. Linear is a long, continuous strand of monomers. Polymers can also form a large network of smaller chains of monomers, which is called branched.
So now we're going to go look at some 3D printing. So I'm going to pass it over to Fahad. He's going to do a quick demo about what 3D printing is like.
The best way to explain 3D printing is with a hot glue gun. A 3D printer acts in the same way, extruding molten material in a predetermined shape, layer by layer, fully formed.
Alright, so now we're in the back of 312, where the 3D Printing Club works. To my left is the CME CNC Delta printer. It's currently extruding PLA at 200 degrees Celsius, and it's printing a water pump.
Last, as part of our Polymer Palooza, we talked about glass transition temperatures. And these are so important for 3D printing because essentially, when you heat this polymer up to the right temperature, it doesn't turn into a soft liquid. It's almost a liquid glass that we can mold with.
This is a spool of PLA plastic for 3D printing. This is a spool of ABS plastic.
So one of the common polymers that are used in 3D printing is ABS. I got a spool here with me. ABS is commonly used in a lot of plastics such as Nerf guns or Legos. ABS is really cool because it can withstand high temperatures and is sort of rigid, sort of not, which makes it suitable for withstanding forces. Cool. And then over here, I've got a spool of green PLA. PLA is another common polymer used in 3D printing. It is a polylactic acid, which means it's biodegradable, and it prints at a lower temperature than ABS, making it much easier on the printers.
3D printing has significant advantages over injection molding. Even though they use the same plastic, 3D printing has the unique advantage of making unique shapes and parts. Injection molding can produce stuff faster than 3D printing, but changing the mold or the shape wanted is extremely labor intensive and expensive.
This is a PLA recycler. It's a capstone project done by some of the members of the 3D Printing Club. Basically, this shredder shreds down failed 3D prints or PLA scrap, and it is melted down through this funnel and spooled back up into usable PLA plastic.
So one of our classmates, Dan, is actually in 3D Printing Club. He's working on seeing how many times you can recycle PLA and still have it work. So every time it goes through that glass transition phase, it can lose its structural value. So we're seeing how many times it can go through that structural value in order to see if it becomes worthless, you're able to keep using it, just testing along those lines.
So, we've got Cure right here. It's got a lion shrine. The shrine file here was scanned by a grad student a couple years ago, so it's a 1-to-1 scale of the shrine itself.
This is MatSE Team 2, and this was a brief look at 3D printing.